Hello everyone and welcome to the Hyperbolas video part 2. We left off talking about the asymptotes, and you might have noticed at the end of the last video I mentioned that I made a mistake on the slope here, so I'm glad there's a video 2 that I can correct myself. So what I'm going to do is going to erase this piece, and we are not wrong about using point slope form. And the other piece that was correct is because we know that the yellow asymptotes go through the center for sure. We definitely want to use the point -5, 3. So that means that if I still don't know my slope, I know that this is x minus -5 here, and I know this is y minus 3. That was correct. Now, I didn't follow my own advice in the last video. How rude. I know that slope is rise over run, and yet I did run over rise. That is not going to help me get to the right answer. Not a bad thing to discuss, but got to admit when I made a mistake, right? So anyway, if I actually did this problem correctly and I counted from the center to one of the vertices of the rectangle, I would go up 2 and over 3 or down 2 and over 3. So my lovely slope is plus or minus 2/3, not 3/2. So again, I'm really glad that we had a video number 2 so I was able to correct that. So the correct answer would be y minus 3 equals plus or minus 2/3 times x plus 5. Now if we move on to the foci, remember the foci are found by using the Pythagorean theorem. And because the hyperbola has a minus in the equation, to find the c value, it is c squared equals a squared plus b squared. And in this example, we already know that a is 2, so a squared is 4. And we know that b squared is 9. So c squared must equal 13. So c must be the square root of 13. And if I would like to find my actual foci, remember this time the hyperbola is y-based because the y is positive in front. So if I know that this is somewhat my major axis here, that I'm changing up and down to find the foci, which would be around here and probably around here, these two red dots. But just to make sure, let's calculate and figure it out. So my x value stays the same. My x is going to stay at -5, which is where the center is, but I'm going to go from y equals 3, and I'm going to go up the square root of 13, and I'm going to start at -5 and then go down by the square root of 13. And remember, it is okay to leave your answers exact, and excuse my arrow, but just to make sure I can show you where this came from, if I want to calculate these algebraically, or I want to graph them, 3 plus the square root of 13 is 6.6. So this first point is really -5, 6.6, which if I look at my graph, -5 up 6.6 does look like it's around here. Awesome. And if I do 3 minus the square root of 13, that would be -0.61. So my other point is -5, -0.61, which would be right about here. So these two red dots would be my foci. And that is a hyperbola that is vertically based. All right, for our last example here, let's go ahead and start by graphing the vertices at 2, 3, and 2, -3. 2, 3, 2, -3. And these represent the vertices. And remember, a hyperbola, if I go back to the previous example or previous examples, a hyperbola only has one set of vertices, and that determines the direction that the hyperbola is going. So if I take a look at this, I notice that the vertices are vertically based. So I know not only does this help me find the a value, it also helps me realize that this hyperbola is vertical. So because I know, again based on previous examples, that my center is directly in the middle in both examples of the vertex in the middle of my two vertices, that means in this example, I know that my vertex must be directly in the middle of these, so I'm going to make a little note, not a vertex, technically it's a center. So my center is at 2, 0, and that will come into play soon. My a value represents the distance from my center to the vertex, so that distance, both directions, would be 3. Next, the problem tells me that my foci are at 2, 5 and 2, -5. And the center, again, is directly in the middle of my two foci. And so the distance both directions is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that means that my C value must be 5 because the C is defined as from the center to the foci, that length. Now, because I know that this hyperbola is vertically based, that means I have this type of equation, y minus k squared over a squared minus x minus h squared over b squared equals 1. So what I need to know is the center, which I know. I need to know what a is, which I know. And I need to know what b is. I don't know b yet, but I know that a hyperbola uses the Pythagorean theorem to find my other piece using this particular format. So I know that c squared, which would be 25, is equal to a squared, which is 9, plus b squared. Or that b squared equals 16, so that means that b must be 4. So now I have enough to write my equation. Y minus the k value of my center is 0 squared over a squared, which is 9, minus x minus h, which is 2 squared over b squared, which would be 16, equals 1. I would say that a better answer instead of y minus 0 would just be y squared over 9 minus x minus 2 squared over 16 equals 1. So this would be my final answer because the question asked at the beginning to find the equation, and we did. And again, I want to point out to you that if I were to draw a picture, I expect this to be vertically based because the y is positive in the front. And so if I were to draw a sketch, my graph would look something like this. It would go like this. And so the two pieces will be facing up and down. All right, that's it. Thank you for sticking with me, and thank you for watching this video, especially to correct the mistake on the previous problem. Good luck!